Okay, so I've been asked to take a look at some questions that are examples similar to question number 2 on the cosine Google form. So it says the minute hand of a clock is 12 centimeters long and the hour hand is 10 centimeters long. Find the distance between the tips of the hands at 9:30 p.m. Answer to the nearest tenth. Fill in the blank for your response. So I'm not going to do that exact same question, but I'll do a similar one. So I'm going to do one where the minute hand of a clock is, well, the minute hand is always longer, right? So let's say the minute hand is 8 centimeters long and the hour hand is 5 centimeters long. And what I want to do is I want to find the distance between the hands, between the tips of the hands at, now the example in the question given is 9:30, but I'm going to pick a different time. So I'm going to say 2:30 p.m. Doesn't matter actually if it's a.m. or p.m. So first thing, let's draw our clock. Now we have 12, 1, 2, 3 is here, 6 is here. It's better for me to draw those in first, just for the proportions. 9, 11, oops, that's actually 10, 11, 7, 8. Now at 2:30, the hour hand, the shorter one, points to 2, and the minute hand points down to 30 minutes. Okay? So what we're looking at, and I'm going to draw it in a different color. If we were to complete a triangle here, we're looking at this. Now, this degrees we should be able to figure out. There are 360 degrees in a circle. So each of the 5-minute segments, because there's 12 of them, is 360 degrees divided by 12. So 360 divided by 12 equals 30 degrees. So each segment is 30 degrees. So that means we can count how many degrees. So we go 1, 2, 3, 4. So we have 4 segments at 30 degrees. So that means that our angle in the middle there is 4 times 30, which is 120 degrees. Now, I'm going to free draw this triangle again. And so what that leaves us with is we have a triangle that goes like this and this here. This degree, which I'll call A just for fun, is 120 degrees. Right here, this side is the shorter hand, so that's 5 centimeters. And the longer hand is 8 centimeters. And what it wants to know is it wants to know this length here. So, sketching this out, I'm writing it out again because I'm going to move to the next page. 5, 8. I know they're centimeters. So let's move to the next page and let's do this work now. This is the hard part, getting that triangle drawn and understanding what the angles are that are in that particular triangle. Now we're using the situation where we're looking for a side. So the version of the cosine law is a squared equals b squared plus c squared minus 2bc cos of a. Okay, so let's put it all in. A squared is equal to, well, I can arbitrarily make one of these b or c. Doesn't matter which one. So according to that, b is 5 squared plus 8 squared minus 2 times 5 times 8 times cos of 120 degrees. So let's see what we get. A squared equals 25 plus 8 times 8 is 64. Why did I need my calculator? I don't know. 2 times 5 times 8 times cos 120 is negative 40. So from that, minus a negative becomes plus a positive. So I get 25 plus 64 plus 40. So a squared is equal to 129. So I'm going to take the square root of both sides. So from that, a is equal to square root of 129 equals 11.35, blah, 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 blah. I would probably, what does the question say? To the nearest 10th. So I would go, this would be 11.4. Now, again, this is just similar. You're going to have to figure out your new triangle. And it's best to sketch that clock first to kind of see how it all lays out. In terms of what are the hands doing at 9:30. And it's actually 9:30 is even easier because, yeah, well, I'll let you see what it is because there's an easier way to do that answer. But this is using the Cosine Law. Okay.